Hi everyone, today I'm going to show you how to do redox half reactions, okay, how to write them. So we'll start off with something that we've been doing, assigning oxidation numbers to each atom. So this is actually the first step. Remember, any element by itself is going to have an oxidation number of 0. Okay, so these are pure elements, meaning just one element by itself. Sodium is +1 because it's an alkali metal, and that makes chlorine here -1. All right, so the next question is usually, what is being oxidized and what is being reduced? So again, 0, 0, +1, -1. So for sodium, it's going from Na and becoming Na +1. Okay, so if the number increases, right, this is being oxidation. So it's losing an electron. Remember, oil oxidation is loss of an electron. Meanwhile, chlorine is going from Cl2 to Cl-1. Okay. Now chlorine, on the other hand, is being reduced, right? The number is literally being reduced. So chlorine's undergoing reduction. Now we're going to get to writing these half reactions. So what I just did was step 1, 2. I did step 1. I looked at the oxidation numbers, figured out what's being oxidized and what's reduced, and I wrote a chemical equation showing how each chemical changes. Now we're going to get to these new steps. Balance each half reaction with coefficients for atoms. So what does that mean? I have one sodium on the left, one sodium on the right. I don't have to balance those. But on the bottom, I've got 2 chlorines on the left side, so I need 2 chlorines on the right side. Okay, so that's step 4 here. Next, add electrons to balance the charges of the equation. So what does that mean? On sodium, I've got a positive charge on the right side, but on the left side, I've got an overall charge of 0. So I'm going to add an electron here to balance that out. Now I've got +1 -1 equals 0 on both sides. For chlorine, I've got 2 times -1 on the right side, so that's -2 on the right side. So I'm going to need to add 2 electrons here to balance out those charges. Okay, and so that is chlorine, remember, is gaining electrons. Oil rig, gain of electrons. Reduction is gain. Now the last step here, balance the number of electrons for both redox reactions. Each one should have the same number of electrons. So how do I do that? I need 2 electrons on the top because I've got 2 on the bottom. I'm just going to multiply everything by 2. So we end up with 2 Na. We get 2 sodium ions plus 2 electrons. And this is going to be our final answers here. We've got oxidation on top and reduction on the bottom. Okay, so went through that pretty quickly, but we're going to do several more examples until you get the hang of it. So we'll follow these 6 steps, and we will, just keep practicing with these half reactions. So here we've got another example, and we have to write both half reactions. So first thing, you want to write all of the oxidation numbers. If it has an ionic charge, that's the same as the oxidation number. So all of these, fairly easy to determine. Now we want to see what's being oxidized. So remember, oxidation is when you gain in number. So 0 to +3, aluminum here is being oxidized. Okay, what's being reduced? That means the iron +2, again, is literally being reduced to iron 0. Okay. So we just went through the first 3 steps here. We did the oxidation numbers, we figured out what's being reduced, what's being oxidized, and we wrote those half equations. We don't have to do step 4 because there's one of each chemical. But step 5, add electrons to balance the charges. Let's go ahead and do that. If I've got +3 here, I'm going to need 3 electrons to balance that out. Again, the overall charge on this side is 0. If I've got 2 electrons, +2 on the left side, I'm going to add 2 electrons here to make the overall charge on both of these equal to 0. Next, I'm going to multiply everything because I want the same number of electrons on both sides. So in this case, I'm going to try to get 6 electrons. And so I'm going to multiply the top by 2 and the bottom by 3. All right, and there you have it. We have both of our balanced half reactions. They have the same number of electrons. That's one way you can check. And you want to make sure the overall charge on both sides of the equation are the same. So in this case, they all equal 0. All right, let's try one last example here, following those same steps. So again, step 1, determine the oxidation number. And then we're going to figure out what's being reduced and what's being oxidized. So any pure element by itself is 0. Because magnesium is in group 2, it's going to be +2 here. And each bromine, remember we want to think about each chemical, is going to be -1 here. And I've got 2 bromines. So oxidation, which one has the number going up? It's going to be magnesium being oxidized. It's becoming Mg+2. Whereas bromine is becoming bromine -1. Okay, each bromine here is -1. So, again, those are the first 3 steps. Step 4, balance each half reaction with coefficients for atoms. So let's see if we need to do that. For the top, magnesium is fine, we have 1 of each. But on the bottom, I've got 2 bromines on the left side. So I'm going to need 2 bromines on the right side. So I'm going to put a 2 there. And that covers step 4. Step 5, add electrons to balance the charges. So here, again, I want an overall charge of 0. So I'm going to add 2 electrons to the right side. For the bottom one, I've got -2 on the left side already. Sorry, on the right side. So I'm going to add 2 electrons here to balance the overall charge, -2 on both sides for the bromine. Check. And lastly, make sure each reaction has the same number of electrons. These both have 2 electrons, so these are going to be our final answers. All right. Hopefully you can follow these 3 examples, and using these rules, you should be able to write your own half reactions. Try those practice problems out. Let me know.